Hello everyone, this is the third video about me creating a buck converter. I copied a schematic from Wikipedia, as you can see right here, and started to build that on a breadboard. The first version was functional, but not useful. It was only able to switch 4 watts of power, but that was okay. Then in the next video I upgraded the flyback diode that goes over the inductor and the load, and started increasing the power. At the end it was able to switch almost 40 watts of power, until the MOSFET started to getting hot, which was the end of the second video. I was already preparing to add a heatsink to that MOSFET to solve that problem. But it turned out I made a mistake. The leg of the resistor was touching the leg of the diode, causing the gate of the MOSFET to be continuously on, but not completely. So it went into high resistance, causing the MOSFET to heat up. With that out of the way, and my now increased load of almost 110 watts, I can now try how far the circuit can actually go. And what will be the next problem that I need to fix? Let's find out. Alright, I got my heat camera set up. Let's test it on a cup of tea. Yes, that works. Okay, now I'm gonna point it at the circuit. You can't see it yet. Now I'm going to up the power to a 12 volt. Excellent. Now I need to set a duty cycle. I do it on my laptop. Set it to 25% and see what it does. Alright, I can see the load, the lamps, and I can see the circuit heating up. Most noticeable is the capacitor. That is the input stabilization capacitor to keep the voltage stable. But since this is a switching circuit at 62.5 kHz, that capacitor has a lot of work to do. It's constantly charging and discharging, and it's not stopping. Well, it's about ramp. No, sorry, at about a 10 watts of power. That's our first problem to solve. Put the power off. 50 degrees. That's more than enough. I have two choices. Either I'm going to add a ceramic capacitor that's much more capable of high frequency charging and discharging, or I'm going to insert a bigger electrolytic capacitor, or maybe even a second one. I'll go to my component bin and see what I think up. Okay, back to the circuit. I made my choice and I decided to get myself a bigger of ceramic capacitor, the biggest one I have actually, and an also bigger electrolytic capacitor. So I'm going to swap that one out. Is it touchable? Yeah, it's cooled down. That's nice. The legs aren't exactly the same size, which, yeah, I need to shorten that. Yes, with this one. Okay, put that in, give that some spacing, and that's the one. And now for the ceramic capacitor. Come on, focus. You can do it. You can do it, right? Oh, come on. Yes. Back to the board. And in focus. Excellent. Okay, back to the thermal camera. Okay, and I'll turn back on the power and see what happens this time. Let's go back to the 12.5 volts. 27 degrees, 28 degrees, 28, 29. It's the diode that's the warmest at the moment. But not too bad. Okay, let's increase the duty cycle a bit to see what happens now. Set at 50%. Oh, load is doing its best. The wires are getting hot. They're getting very hot. That's a problem. Yep. Time to shut that one down. And yeah, I guess I have to fix those wires now. How shall I do that? I also am going to cover up the lamps. That is my load with a receipt from, what is it? Local market. So those lights won't blind me when the load goes up to 100 watts. Okay, the wire problem. That one first. Those wires are attached with, let me see that, crocodile clips from my power supply. I'll just disconnect this one and the other one. So those two, they can leave. I got me 2 pieces of copper that go into the breadboard. One for ground. It's actually quite thick. Oh, that one launched itself. Bigger pliers. Like they don't want to. Yeah, but they have to. Okay, I need another one. Number 2. That goes into the positive rail. Just any place will do. And also. Alright. Attach ground. And positive. And now those wires are entirely engineered out. Removed. Okay, back to the thermal camera. This is how you turn a thermal camera into a webcam. Just some sticks and just swing it. All right, power. Set that back to the 12.5 volts. This is about 25 to 30 watts. Temperature seems quite stable. Wires are not getting hot anymore. Capacitor still cool. At 25 watts I said. 25, almost 30. Okay, let's increase that. And set the duty cycle to 60%. It was now at 50. I'll make it 60. Okay, that's about 37, almost 40 watts. Still going strong. Nothing about to blow up. Okay, let's see, 70%. 42 watts. And the heatest part is either the diode, the flyback diode. Yeah, that's the hottest part. Okay, some more, 5 times, 45 watts. About 50 watts, still going strong. Okay, that's all she got. 3.3 times 16 is 48, 52 watts of power. And it's still going strong. I'm quite happy. Nothing is on fire. The wires are 55 degrees. I think that's the bottleneck at this point. I need bigger wires to the circuit. Okay, so at the end of the previous video, the circuit was switching about 40 watts, and at that point the MOSFET was getting hot, and that overshadowed some other problems, the capacitor getting hot and the wires getting hot. Those two problems are now solved. Also the MOSFET problem, that was a mistake I told you earlier. And now I have a stable circuit that's not overheating and switching the load pretty fine at 50% duty cycle, and an output of 52 and a bit watt of power. So that's quite an improvement, and let's see what we fix next time. It's gonna be the wires anyway. Those are getting hot also. Thank you for watching. Bye.